Hi, welcome. This is just a short presentation on engineering and kind of what it's all about. So, oftentimes when we think about engineering just kind of informally, we'll get ideas like engineers make things, or engineers are creative, or engineers construct things for people. Maybe on the electrical or computer side of things, maybe you think engineers do programming, or engineers do things that make money. While these things may be true, they really do miss something because artists also make things and are creative, and artists make things for people. Artists sometimes even do some programming, and they definitely make money for their art. So we haven't really distinguished engineering from art. We also haven't really distinguished it from science or technology or really even the hobby construction of things. So let's think about what is engineering, but let's try and now define it so that we don't include all those other things in there that are not engineering. So these definitions here are way too broad. So a more robust definition of engineering is that engineering is applying math and science to solve practical problems. Now, there's a lot packed into this sentence. So we're saying that engineers are not necessarily looking to create new math and science unless they have to. They're more concerned with applying the math and science that's already there. That's not to say, though, that engineers will get out there and create math and science when necessary, but that's not really the goal of engineering. Math and science is the tool that engineers use to solve problems. And then the other aspect of it that really separates it out from more just the artistic application of art and science is that the problems that engineers solve have to be practical problems. So they can be things like problems with the infrastructure, so civil engineers designing roads and bridges and things and airports and things like that. They can also be problems, practical problems of how do you design a process that makes money, or how you've got this oil that's under the ground. How do you extract that oil economically and safely, causing a minimum of environmental problems and process it? So there's a lot packed into this definition, but this is a really good, robust definition of engineering. And then sometimes there's some confusion between engineering and other roles. So let's kind of take a look at all the things that are engineering, but then also kind of close to engineering. So there's math and science, and also computer science. So those kinds of roles would be called scientist, computer scientist, mathematician, and they would be mostly concerned with understanding how things work, the creation of new math, the creation of new science, or with computer science, really the architecture of the program or the software that you're putting together. Then you also have technology. So this is really just more the use of technology. So this would be someone that would be doing hands-on application using technology in the lab. Or if you have a process, this would be someone who would be the process operator of the process. So those are different and separate from engineering. Of course, there's gonna definitely be some overlap. Again, sometimes engineers have to go out there and create that new math and science. Sometimes engineers have to work with existing technology or create new technology out there. So there's definitely overlap, but there are three separate roles in the industry. So looking at, let's say we've got one particular company that's making engines. So how would this be different? So let's look at the mechanical engineer. So the mechanical engineer in this company working on this project is trying to improve the engine, and they're doing that by applying the math and science. So they're using some kind of computer modeling to model the flow of the fluid through the mechanical system, and then they went and designed a set of experiments from the results of their model to find that most optimum shape of the intake for that system. And then they took that experimental data and analyzed it, and they used that to come up with a final design. So you could see not a lot of hands-on application in here, but a lot of applying math and science, a lot of determining what experiments to use, and then analyzing the experimental data. Let's look at the hands-on role. That would be the mechanical engineering technologist for this project. So he or she works in the lab and they're doing the hands-on analysis and they're performing the experiments that the mechanical engineer is telling them to do. But a good mechanical engineering technologist and mechanical engineer are working hand in hand, because the mechanical engineer may want the technologist to do something that's just not practical and not the best way. The technologist is the expert on the equipment. And so they're going to work together. The engineer is going to take the design role in the experiment, but they're also going to get that feedback from the technologist. And then the technologist is going to do the experiments, collect all the data, but then hand the data back to the engineer for analysis. But again, it's very much a hand-in-hand kind of role between the mechanical engineer and the technician or technologist that they're working with. Now let's look at a science role. So let's say we've got a chemist on this project. So the chemist is looking at fuel additives, and they're doing that by studying both the chemical structure and trying to understand the science of combustion and really be on the bleeding edge of the science of combustion. Let's look at what the chemical engineer would do, though. The chemical engineer would then take maybe this list of top 10 best additives from the chemist and then say, well, how does this work in a real system? So then they would design experiments to test it in the lab scale and then maybe scale it up to a real system and see which one really has the best performance. Or sometimes, as a chemical engineer, you might be trying to figure out, now that you've got the best additive, how do you produce it in large quantities and manage the environmental issues and make for sure that your production's at low cost and it integrates well with the rest of your plant. So hopefully you can see these two engineering roles in a project, and then you can see these two roles that are not engineering roles, but they're really working hand in hand. The chemist is giving the cutting edge research that the chemical engineer is then using for his or her research, and the chemical engineer is feeding back, hey, this is what we got in the real system, back to the chemist. The same way that the mechanical engineer and the mechanical engineering technologist are working hand in hand. So let's look at how to describe the engineering role. So sometimes you'll see folks give definitions like this, like mechanical engineers deal with engines. Again, that really doesn't describe the engineering role at all, because if you own a car, you deal with engines. If you're a mechanic, you deal with engines. If you're a mechanical engineering technician that's working in a lab where you're studying engines, you're dealing with engines. So that's a very poor definition. If we want to really describe that engineering role, we want to use these words, so like design, improve, things like that. And we don't want to say mechanical engineers design and improve mechanical systems, because then that sets up a circular definition of mechanical in the front, which is then explained by mechanical in the back part. So instead of saying just mechanical systems, we might say systems with moving parts and systems that must withstand a static load. So we kind of got both aspects of that. So when you're talking about the engineering role, use these types of words like engineers design, engineers develop. Engineers don't construct bridges and roads, but engineers lead the construction of bridges and roads. Engineers manage projects with bridge construction and road construction. Engineers might use the analysis of a particular math or science aspect to solve that practical problem. So think about using very careful vocabulary when you're talking about the engineering role. Make for sure that you separate it out from the role of the scientist, the role of the technician or technologist, and also the role of just the casual user or the artist. So for summary, engineering is applying math and science to solve practical problems. And again, make for sure that you're being very careful when you're describing the engineering role, make for sure that it's clear that you've separated the engineering role from all those other roles. Thanks for watching.